Chapter 10 is multi-factor models of risk and return. And we're moving on from Chapter 9, where we introduced our first factor model, the capital asset pricing model, and Chapter 8, where we did a little bit more regression math, to now move to these multi-factor models. And the idea with a multi-factor model is there's more than one thing to describe return, so not just the market. And the tool that we're going to use is a multivariate regression. We're going to use to determine if something really does describe returns. Is it statistically significantly different from zero, the relationship? And although we'll see that statistical significance is not enough, because there must be some economic underpinning, else we're going to conclude something very silly. But given that we believe that there is some reason to think that a factor describes returns, then we can use this statistical tool to see if there's really something there. Now, the text spends a lot of time covering the proofs and derivation of something called the arbitrage pricing theory. And that's the underlying basis for the use of these multi-factor models. And arbitrage pricing theory is essentially the law of one price. It says if the relationship between an asset or a portfolio's returns and the returns of a factor, which is measured by the factor beta, is the same for two portfolios, then the expected return of these two portfolios must be the same. So in simple terms, if portfolio 1 has a CAPM beta of 1.2 and portfolio 2 has a CAPM beta of 1.2, then both of these portfolios should have the same return. And if I go long portfolio 1 and short portfolio 2, then these returns should offset. Another application that the text does is instead of relating two different securities to each other, we can relate all the securities to a factor, and that's going to allow for this sort of complex portfolio construction that, again, we're really going to skip. We're just going to skip this theory, and we're going to move right to this application, which is these multivariate regressions. And I just want to give you a couple of quick notes on the mechanics of regressions. So first, how are we going to write this stuff? What do our notations, what do our subscripts look like? And so I want to talk about the use of time subscripts. So if I have the return of some stock I over 60 months, and I have the return of the market over 60 months, then technically I would write this with both the security and the time subscripts. I would have RI, T and RM, T. And so if I would have RI1, RI2, all the way back to RI60, I would have RM1, RM2, RM3, all the way down to RM60. But most of the time when we write this, you can see we're just going to drop the time subscripts. But we know that there are 60 returns for the stock, 60 returns for the market, and 60 error terms, but for the most part, we'll drop that. The next thing I want to talk about briefly is this idea of should we use risk premia, or should we use returns? Should we use little r versus big R? That's the notation in the text. And remember that big R is equal to little r minus the risk-free. And the answer is we should always really be using the risk premium. But because over the last 5 years, the risk-free rate has been very small and there hasn't been not a lot of variation, very small and not much variation, the regressions using R versus little r versus big R, using the return versus the risk premia, they give very similar results, and we'll look at that in a second. The second thing is, what should I be using for my market index? Should I use the S&P 500, or should I use this, and this is a very common market measure, it's called the Center for Research in Securities Prices, the CRSP Value Weighted Index. It's very common to use the S&P 500 as the market proxy on the right-hand side. But since the S&P is made up of large stocks, which is the large market cap, which is price times share, we know that the size of a stock affects returns, and so regressions using the market versus regressions using the S&P 500 actually can produce big differences because what we signal as MKT, this CRSP Value Weighted Index, contains lots of stocks, which includes small stocks, whereas this just contains big stocks. And so therefore we should use the MKT, which is the CRSP Value Weighted Index. And here's a little link to this. And I'm just going to go to a spreadsheet and show you the difference very quickly.